So, good morning or good afternoon, folks, and welcome to the presentation. So, what I'd like to do today is talk just a little bit about why you should take Cloudera's training, and then we'll talk in specific about the administrator course. So, we have just updated our administrator course. It is now a 4-day hands-on course. So, I want to tell you a little bit about what's in that course. And what kind of hands-on exercises you would expect to do in the course. We'll then look at a couple of sections from the course. So I want to show you just a little bit of the course that covers HDFS high availability, because that's obviously of interest to a lot of people, and also just an example of the kind of configuration options that we cover during the course. And then, as John mentioned, later on there will be time for questions. So if you do have any questions, as John said, please type them into the Q&A panel. All right, so why should you consider Cloudera as your training partner? Well, because Cloudera is far and away the leader in Hadoop training worldwide. We have the broadest range of courses of anyone out there. So our courses include courses for developers, for system administrators, for data analysts, people who need to use tools like Hive, Impala, and Pig to analyze data in the Hadoop cluster without needing to learn Java MapReduce. For people who want to use and implement and develop to HBase, and for data scientists as well. We have an introduction to data science course. We also have a lot of online material so that you can take without needing to even attend a course. Our instructors have been teaching Hadoop for longer than pretty much anyone else. We've taught over 15,000 people since we started teaching in 2009, and we're teaching thousands and thousands every year. We also have the only real Hadoop certification that is considered relevant by industry. We've certified over 5,000 people in developer, administrator, and HBase topics for Hadoop. And we update our courses regularly because Hadoop, as I'm sure you know, is very rapidly evolving. So, as I say, we've just updated our administrator course to a 4-day course, but we're constantly revising our courses as well as developing new courses. You can take our training anywhere in the world, pretty much. We offer training in over 50 cities worldwide, and we also offer online training as well. So even if you're not geographically close to somewhere where we offer in-person training, then you can take our training online. CDH, our distribution of Hadoop, is deployed more than all the other distributions combined. So the chances are, if you start using Hadoop, if you go into a new company which is already using Hadoop, the chances are pretty strong that they're already using CDH. And while our training courses are relatively distribution agnostic, we do, from time to time, look at the features that CDH includes because we believe that those are the key features that you'll need. And when you take our training courses are really in-depth and really intensive training courses. We have a lot of hands-on exercise. And by the time you've finished one of our training courses, you really are able to go out and use Hadoop in the real world. Specifically, if you take our system administrator training course, then that's part of a complete learning path that we have for system administrators. So you can take our admin training course, which is what I'm going to talk about in just a minute. But then after you've taken our admin course, we have other courses which are logical follow-ons to that course that will really round out your experience and your ability to use Hadoop in the real world. So we have Cloudera Enterprise training. That's where we teach you exactly how to use Cloudera Manager. Cloudera Manager is the most fully featured tool available to install, configure, monitor, manage, and maintain your Hadoop cluster. We have a set of HBase training, so a HBase training course, which is a 4-day course, which will teach you how to install and use HBase, which is a real-time database which sits on top of HDFS. So we talk about developing for HBase, installing, configuring HBase. So if you're an admin who needs to deal with HBase, that's a very good follow-on course. And then, as we know, system administrators, certainly in the Hadoop world, tend to have something of a crossover role. So you're not just managing the cluster, but people will come and ask you to actually manipulate the data in the cluster and maybe even find answers to questions that they have from the data in the cluster. So we recommend that if you are an admin, to really round out your Hadoop experience, you also take our data analyst training. The data analyst training course is a course which teaches you how to use some high-level abstractions called Hive and Impala and Pig, which kind of sit on top of your data and mean that you can get answers to the questions that you have from your data without needing to be a hardcore Java programmer who really knows Java MapReduce. So let's talk about what's in the administrator course. So our administrator course has just been updated to 4 days. It covers the very latest features of Hadoop. Here's what we talk about. We talk about the core technologies of Hadoop. So that is HDFS, the Hadoop Distributed File System, and MapReduce, which is the way of processing the data. So we look in quite some depth at how HDFS works and how MapReduce actually works on the cluster. We look at all the different cluster daemons. We see where they live on the cluster and exactly what they do. We talk about populating HDFS from external sources. So obviously you need to get data into HDFS before you can start processing that data. There are several ways to do that. We look at a number of different ways, including Scoop, which is a tool which allows you to ingest data from your traditional relational database system into Hadoop in a very high-speed, very efficient way. And we talk about Flume. Flume is a tool which allows you to ingest data as that data is being generated. So if you've got web servers or mail servers or sensor networks which are dynamically generating data, then using Flume you can import that data straight into HDFS without having to, wait until the end of the day and then roll logs and then manually input the data. So we talk about those, and we do hands-on exercises with all these things as well. We talk about how to plan your Hadoop cluster. So what hardware should you be looking at buying in order to implement a Hadoop cluster? What kind of software should you be running? What are the software considerations in terms of any operating system tweaks that you need to make in order to really optimize your Hadoop performance? We talk about deploying the Hadoop cluster. So how do you actually install Hadoop? And as we're doing that, students on the course build their own Hadoop clusters. So we spin up machines for them in the cloud, and each student will actually deploy and build their own Hadoop cluster as we go. We talk about installation of Hive and Pig and Impala, because again, in more and more Hadoop installations, we're seeing that people are not just writing Java MapReduce, but they are using these high-level abstractions. So as a system administrator, we talk about what you need to know in order to install and deploy these things, and also to monitor them. We look at typical Hadoop architectures in terms of where the clients live. Do the clients live on individual machines, or do you have edge nodes, bastion boxes, which are able to access the Hadoop cluster? So we talk about that kind of architecture, and we talk about exactly what you need to install on those client nodes in order to allow people to access the cluster. We talk about Cloudera Manager. Cloudera Manager is a product from Cloudera, which is absolutely the best way to install, configure, and manage your cluster. So we look at that, we look at the features that provides. We talk about HDFS high availability. So I'm going to talk a little more about that in a couple of minutes. But HDFS high availability basically means there is no single point of failure on your cluster as far as the data storage is concerned. So that's really important for a lot of people in a production environment. Again, I'll talk about that in a minute. We talk about Hadoop security. So it's all very well configuring and installing your Hadoop cluster, but how do you make sure that only the right people get access to the right data on the cluster? So we talk about the security options that are available. We talk about how to configure your Hadoop cluster using Kerberos. We look at job scheduling on the cluster. So again, it's fine to build and install this cluster, but what happens when you've got lots of people who all want to access the cluster at the same time, who all want to run jobs on the cluster, potentially, who all want to run really big, really time-consuming jobs on the cluster? You need some way of scheduling your jobs on the cluster, and we talk about the different schedulers that are available, again, how to configure those schedulers, and of course we do hands-on exercises for these things. And then we talk about cluster maintenance, monitoring, troubleshooting, and optimization. So it's very easy, especially using Cloudera Manager, to stand up a small proof of concept cluster, something like that. But as your cluster grows, how do you make sure that the cluster is actually performing as well as it should be performing? That's what we talk about in the later sections of the course when we look at optimization and monitoring and troubleshooting, because things can go wrong, things will go wrong. That's just the nature of the world. So how do you actually monitor, proactively monitor, and try and spot the problems before they become really big problems? If they become big problems, then how do you solve those problems? So we have a kind of packed 4-day class, and during the class, as I say, we perform several hands-on exercises. So we first of all deploy Hadoop in pseudo-distributed mode. That's where Hadoop is just running on a single machine. Then we deploy a complete multi-node Hadoop cluster, so every student builds their own cluster. We do hands-on exercises to import that data using Flume and Scoop. We install and use Hive and Impala to manipulate the data. We use Hue, which is another open source tool, which is a great tool for allowing people access to the cluster, even people who don't have kind of command line savvy, data analysts, for example, who want to be able to issue Hive queries, which look very much like SQL queries, or want to be able to use Impala, which again looks very much like SQL, to access the data on the cluster. And especially when you need to limit the people who can access the cluster. So we install and configure Hue. We configure HDFS high availability. So again, we configure HDFS so there's no single point of failure on the name node. We configure the fair scheduler, which is a way of allowing multiple people to use the cluster at the same time, and so on and so on. And we end up with some troubleshooting labs where we introduce problems onto each student's cluster, and then you will get to try and diagnose and cure those problems. So it's a very, very packed 4-day class. It's a lot of fun to teach. It's a lot of fun to attend. And this is basically the outline of the class. So we start with some chapters that are about sort of an introduction to Hadoop, making sure that everyone really understands how things like HDFS and MapReduce work. Then we go on to talking about planning, installing, and configuring. And then finally, we look at cluster operations and cluster maintenance. So to give you some kind of idea of the sort of things that we talk about in the course, I want to just show you some small parts of a couple of the sections of the course. And the first one is an overview of HDFS high availability. So these slides come directly out of the course. So we talk, after we've installed the cluster and we've done some basic configuration on the cluster, we then start talking about possible problems. And one of the possible problems is the fact that if you have a single name node, and obviously, you know, in order to follow along with this, you need to know what these things are. So I'm assuming that you have some sort of basic knowledge of Hadoop, and that the name node is a master node which stores information about all the data that's stored on the cluster. In the traditional Hadoop implementations, there was a single name node, a single machine which had information about all the cluster's data. And if that name node failed, then the cluster was unavailable until you could replace or repair that name node. That's a single point of failure, and for a lot of organizations, that's just not acceptable. So in CDH and in later versions of Hadoop, we now have high availability name node, and that stops the name node from being a single point of failure. And it's worth saying that to a large extent, it's not as big a deal as it sounds like to have a single name node, because the name node software is really rock solid software. The name node software is very, very unlikely to crash. And when we talk about configuring, we talk about the kind of hardware on which you should run the name node. And when we talk about that, we explain that the name node hardware should be very high quality hardware. You know, you should have dual hot swap power supplies, you should have dual bonded Ethernet, and so on. So it's unlikely, or at least fairly rare, that the name node will crash or that the machine will crash. However, if you've got a cluster which needs to be available all the time, you may still need to do maintenance on that name node machine. Maybe a disk fails on the machine, you've got to replace the disk. Or maybe you need to do an operating system patch or an operating system upgrade, or even to upgrade the name node software itself. With a single name node, that is a problem. But with high availability of the name node, it ceases to become a problem. So, with HDFS high availability, we actually use 2 name nodes, not 1. So we call these the active name node and the standby name node. The client, that is the people who are accessing the cluster from outside, always contact the active name node. But the data nodes, those are the machines within the cluster that actually store the data. The data nodes actually connect into both the active name node and the standby name node. So every 3 seconds, these data nodes are heartbeating in to both the active and the standby name nodes. And as they're doing that, that means that the standby name node contains a completely up-to-date copy of all of what we call the name node's metadata. That is the information in the name node about where all the data is on the cluster. But if you're changing data on the cluster, as a client, you connect into the active name node and you change that data. The standby name node needs to have some way of discovering what that changed data is. So the active name node writes any changes to its metadata to a set of machines called journal nodes. Those journal node daemons typically run on your master machines on the cluster. And the active name node writes to the journal nodes, and the standby name node is monitoring the journal nodes. And anytime it sees a change, it immediately mirrors that change in its own internal metadata. What that means is that the standby name node is now absolutely and completely up to date with the active name node. And the way the journal nodes work is very clever. It's really pretty complex. We have multiple journal nodes so that the journal nodes are not a single point of failure. If the name node, the active name node, was just writing to a single machine, then that single machine would be potentially an SPOF. In order to avoid that, we have multiple journal nodes. We call them a quorum of journal nodes. Typically, there are 3. If you want really high availability, you might even use 5 journal nodes. And the software that actually does the writing to these journal nodes is called the Quorum Journal Manager. It's a piece of software which is actually built into the name node. And the journal nodes talk between each other. They coordinate with each other to make sure that they all have the most up-to-date information from the active name node. So they use a really very neat algorithm called Paxos, which makes sure that even if one of the journal nodes goes down, then the data is still completely up to date. This is one of those problems that is actually a really hard problem to solve in distributed computing. But it turns out that some very smart people have worked on this, and the journal nodes use this Paxos algorithm to make sure that even if one of them goes down, then we still have the very most up-to-date data there. One thing which, if you are used to the traditional HDFS architecture, you might be wondering is, where is the secondary name node in all of this? And the answer is that in HDFS high availability configurations, you do not have a secondary name node. The standby name node, in fact, takes over that functionality, and the standby name node checkpoints the metadata for the active name node periodically. So with high availability HDFS, we actually have 2 modes of failure, manual failure and automatic failure. So if the active name node fails, then the standby name node needs to take over. If you configure HDFS high availability for manual failover, then you have got to invoke that changeover. And honestly, most people would not want to configure their cluster in this way, because the whole point of having high availability for the name node is that if the active name node goes down, the cluster does not go down. The standby name node immediately takes over. If you're configured in a manual failover scenario, then you've still got to wake up to that pager going off at 3 a.m. and actually invoke the changeover yourself. So, in fact, pretty much everyone is going to configure HDFS for high availability using automatic failover. And with automatic failover, the software actually detects the failures itself and automatically promotes the standby name node to be an active name node. So automatic failover is based on another Apache open source project, a thing called Apache Zookeeper, and essentially a daemon on each of the name node machines called the Zookeeper failover controller monitors the name node and uses Zookeeper, which is again a distributed configuration system. So each of those Zookeeper failover controllers talks to Zookeeper and tells Zookeeper which is the active, which is the standby node. If the active name node fails, then the Zookeeper failover controller will effectively tell Zookeeper that he's no longer active. The Zookeeper failover controller on the standby node will see that and will immediately tell the standby name node that it now should take over and become the active name node. So the architecture, if you have automatic failover, looks a little more complex now, but it looks something like this. On each of the two name node boxes, you now also have the Zookeeper failover controller daemon running, and the Zookeeper failover controllers both talk to Zookeeper. Once more, Zookeeper is a distributed configuration system, or configuration management system, I guess. So you would have typically 3 or maybe 5 machines running Zookeeper, and the Zookeeper nodes all talk to each other. So these slides are an introduction to HDFS high availability. What we do in the class is that we then dive into a little more depth about each of these components. We talk about how to configure each of these components, the ways that, that things can go wrong and how to avoid that. And then students actually build clusters with a high availability name node. So, as I say, that's kind of an introduction to our name node high availability section, but hopefully that's giving you some idea if you didn't know how HDFS high availability works. At least hopefully now you've got some idea of how it hangs together. Then the other thing I wanted to show you is a portion of one of our chapters which talks about some of Hadoop's more advanced configuration options. And really, this is just to show you that we really do get deep down into the configuration options that you can use to make sure that Hadoop is working as efficiently, as effectively as possible. So, for instance, we talk about configuration options like dfs.namenode.handler.count. So this is basically the number of concurrent requests that the name node can handle from data nodes. So each data node heartbeats into the name node every 3 seconds. This is the number of threads that the name node can use to handle those requests. And what's the reason I have this slide here, and I wanted to show you this slide, is just to show you that we don't just say, here is a configuration and here is its default value. Cloudera has been working with customers for many years. We've worked with many, many customers on clusters ranging from 4 or 5 machines up to several thousand machines. And over that time, we've generated some best practices and some best case on some configuration parameter settings that really will give you the best performance out of your cluster. So when you come on this course, not only are you learning what these configuration parameters do, but we're also giving you solid, concrete advice as to what to set these parameters to get the best performance out of your Hadoop cluster. So for example, although the default for namenode.handler.count is 10, our actual recommendation is somewhat different to that. It's the natural log of the number of nodes on your cluster multiplied by 20. So as we show you, If you don't set that high enough, then you will get error messages in the logs. If you see those error messages, then this is a configuration parameter you need to tweak. But as I say, the values that we give you are values that we've generated and we've come up with after years of working with clusters of vastly varying sizes. Another interesting one that we talk about, dfs.datanode.fail.volumes.tolerated. These are all very verbose, very wordy configuration options. But this is a really, really important option if you have a cluster where your data nodes have large numbers of disks. And more that's the case these days. People are not running data nodes with just 4 disks. People are running data nodes with 8 or 12 or even 24 disks hanging off of them. What this parameter does is it says if a disk fails, or I should say, what this parameter says is how many disks on a specific data node can fail before the data node daemon shuts itself down. Now, if you just have a couple of disks on a data node, then the default, which is 0, is absolutely right. If a disk fails, then the data node should just shut itself down. All that data should be re-replicated on the cluster because there's probably something wrong with the box itself. But if you've got 12 or 18 disks hanging off your data node, then the chances are that if a disk fails, it's just because, well, because that disk failed, because disks do go down from time to time. But if I've got, say, 12 2-terabyte disks on my data node, so a total of 24 terabytes of storage space, and one of those disks fails, I absolutely don't want the data node to shut down and to re-replicate potentially 20 plus terabytes of HDFS blocks across the network. Instead, I want to be notified, and that's where tools like Cloudera Manager come in, but I'm okay with one or maybe even a couple of the disks failing on a specific data node. I can just schedule during my next trip to the data center to replace just those disks. Now, obviously, you don't want to turn that value up too high. If, say, you've got 12 disks on the machine and 4 or 5 of those disks have failed, then that's a huge red flag. That suggests to me that there's something gone horribly wrong with the machine itself, and I need to get in there and work out what the problem is. But 1 or 2 disks out of a dozen failing should not be enough for me to shut down the entire data node. So this is a good example of the kind of configuration parameters that we talk about that are more important if you've got larger clusters. And just to skip through a couple of the others, because I do want to leave plenty of time for questions. But again, we really kind of delve deep into the configuration parameter settings. So let me just highlight a couple here. MapRed reduce parallel copies and task tracker HTTP threads. These 2 parameters are actually complementary parameters. So if you know a little bit about how MapReduce works, then you will know that the mappers write their intermediate data to their local disks, and then the reducers pull that intermediate data down to their local disks. So what mapred.reduce.parallel.copies specifies is how many mappers can an individual reducer connect to simultaneously in order to pull that intermediate data down. And the default is 5. We recommend that you actually turn that up to a minimum of 10, but again, to actually the natural log of the number of cluster nodes times 4. So each individual reducer can connect simultaneously to this many mappers. But on the other side of that is how many connections can these mappers, and actually technically it's the task tracker daemon itself, how many connections from reducers can a task tracker daemon handle simultaneously? And that's tasktracker.http.threads. The default is 40. Again, we recommend that you turn that up. We recommend you turn it up to 80. So that says that each task tracker can cope with 80 simultaneous connections in from reducers. And hopefully you can see that these 2 configuration parameters are kind of very much complementary. The higher you turn up MapRed reduce parallel copies, in other words, the number of mappers that each reducer can connect to simultaneously, the higher you'll need to have task tracker HTTP threads set to, because that's the number of connections, incoming connections that the task tracker can handle. The more task trackers a reducer can connect to, the higher that number is going to have to be. And then the last one I want to mention is just map-read reduce slow start completed maps. Again, this is an example of one of the configuration parameters that a lot of people aren't even aware of. But if you are aware of it, it can actually provide you with really much better cluster utilization and much better cluster performance. So when the job tracker is scheduling jobs on the cluster, it schedules all the scheduling tasks on the cluster. It schedules all the map tasks and it schedules the reduced tasks. And the question is, once a job has started, how long is it before the reduced tasks get scheduled onto the slave nodes? And the answer is that by default, the reduced tasks are scheduled after just 5% of the map tasks have completed. And the reduced tasks can then start connecting into those completed map tasks and pulling down the data. But here's the problem. If you run a huge job on the cluster, which is going to take hours and hours and hours to run and requires a lot of reducers, then as soon as 5% of map tasks have completed, all of your reducers are scheduled on the cluster. And what that means is that if I then submit a job, which is maybe just a really quick job, which only needs a few reducers, then my job still has to wait for yours to finish because you're using up all the reduce slots on the cluster. Instead of that, it would be good if we could control the time that your reducers were launched such that they waited until most of your mappers were finished. That way my job can get in there, can use the reduced slots that are available, can complete its job while your mappers are still running. So that's the value of this parameter, map-read reduce slow start completed maps. The default is that the reducers start after just 5% of the mappers have completed. We suggest that you turn that way, way up. We suggest that you turn that up so that the reducers are not scheduled on the cluster until 80% of the map tasks have completed. Now, that does mean that when the reducers start up, they will immediately be connecting to a lot of completed mappers to pull down their data. So there will be sort of higher network utilization. And if you turn it up too high, then all the mappers will have finished before the reducers have pulled down most of their data. And that can cause problems with jobs being a little slower. But by turning that up, we find that you get much, much better cluster utilization across the cluster, especially if you've got a larger cluster, especially if you've got a more heavily used cluster. So that's really what I wanted to show you, is just a couple of tiny sections from our administrator course, just to hopefully give you an idea of the kind of material that we have, the quality of material that we have, the fact that we're not just reading the contents of Hadoop, the definitive guide. What we're doing is not only telling you what things do and how they do them, but also suggesting to you the best ways that you should configure your cluster so that you will actually get the best performance from your cluster. Hadoop system administration is not an easy thing. If you're already a system administrator, then you know how to drive Linux, and you probably know about networking and that kind of stuff. But still, Hadoop is very much a complex system with many, many moving parts. And in order to become a good Hadoop system administrator, you really do need training in the subject. And I would suggest that Cloudera's training is by far the best training that's available. So, having said that, let's take some questions. So I'm going to pass things back to John. Hopefully John's been monitoring the questions and he can pass them on to me.
Thank you, Ian. Yes, we have. I'd like to remind everybody that if you do have a question, you can ask it using the Q&A panel, which is located in your WebEx console at the top of your screen. If you don't see that, look in the options drop-down, and there should be a Q&A button that you can hit there to access the panel. And also, just like to mention that you can find any of the administrator or data analyst trainings, as well as our other training courses and their schedules available at university.cloudera.com. So if you're looking for any specific geo or time, go ahead and look at university.cloudera.com and you will see our full schedule that's available to date. And so the first question here for Ian, which CDH distribution is high available production ready?
So CDH, high availability for the name node was introduced in CDH 4.0, but the version, and it's absolutely production ready as of 4.0. The 4.0 version required you to store that shared data. If you recall, I showed you the journal nodes there, where the shared data, the shared metadata was stored. In the 4.0 version, we didn't have the journal nodes, so you had to have some kind of NFS filer on the system in order to store that shared metadata. And that meant that that NFS filer was, technically speaking, still a single point of failure. The journal nodes were introduced with 4.1, so I would say that really, if you want HDFS high availability, CDH 4.1 or above are the best choices.
Thank you, Ian. Next question. Can we configure multiple master nodes? And do you think, or did we think about Hadoop, or did we think about backup and restore in case of disaster recovery? Can we modify the block size?
That's a bunch of different questions there. So yes, absolutely, we think about disaster recovery and backup and restore. And in fact, in the admin course, we do have a section where we talk about this kind of thing. Because honestly, backup is a huge issue because your Hadoop cluster is storing massive amounts of data. So to some extent, your disaster recovery scenarios are not specific Hadoop. I'm sorry, I'll try that again. They're not specific to Hadoop. They're really how do I back up huge amounts of data problems. But we talk about that in the class. One of the other questions there was, can you change the block size? Absolutely, you can change the block size. The block size is actually specified as a client-side parameter. So each client, when it's writing blocks to HDFS, specifies the size of the block. The default block size for Hadoop is 64 megabytes. Our recommendation is certainly that you increase that and that you store the files with a block size of 128 megabytes.
Great answer. Thank you, Ian. So the next question, which I believe you may have covered in the presentation, but it doesn't hurt to reiterate. What prerequisites do you have for the admin course?
Okay, that is a good question. So I would expect that someone who attended the administrator course would certainly already have knowledge of Linux. If you're already a Linux system administrator, then so much the better. But certainly you need at least some basic Linux knowledge. If you don't know how to edit a file or look in a directory, log on to a Linux system, that kind of thing, then you're really going to struggle because Hadoop clusters really all run on Linux. So you're going to need at least some basic system Linux knowledge. The people we see on our course do range in background. So some folks are people who've been traditional system administrators for many, many years and are now being asked to also administer their Hadoop clusters. Other people are developers who want to start using Hadoop, and they're the person in their organization who's been tasked with, okay, you go away and stand up your proof of concept cluster then. So these are people who are far more of a developer background, but still have some Linux experience, and they come into the course needing to know how to administer their clusters with no sysadmin background. The one thing you don't actually need is you don't need to understand how Hadoop works to start with, because we talk through all of that stuff for you.
Thank you, Ian. So now for someone who is new to Java and Hadoop, what kind of training would you recommend they start with?
What I would suggest is if you're brand new to Hadoop, brand new to Java, then on the Cloudera website, if you go to university.cloudera.com, then we have a set of videos which we call Hadoop Essentials. And that's a set of about 6 videos, each of which is around 45 minutes to an hour long, which really introduces Hadoop, you to Hadoop. It talks about what Hadoop is, the kind of problems it can solve, gives you some basic understanding of HDFS and MapReduce and the other projects in the Hadoop ecosystem. So I'd suggest that the first thing to do is to watch those videos. If you're new to Java, then if you're going to become a Hadoop developer, you're going to need to learn Java if you're going to write MapReduce. So honestly, there are all sorts of Java tutorials and Java books out there, and you just need to find one that suits your style of learning. But then from our point of view, after you've viewed the Essentials video, I would then suggest that, you know, decide which learning path you're most interested in. Are you interested in becoming a Hadoop developer or an administrator? And then again, if you check on university.cloudera.com, you'll be able to find our classes and our learning paths. And certainly, if you're going to be an administrator, then our admin class is a very good class to go on. If you're going to become a developer, then I would suggest you check out our 4-day Hadoop developer class.
Thank you, Ian. The next question here, does the course cover, the course being the admin course, does it cover other things in the ecosystem like HBase, Hive, etc.?
We cover a lot of the ecosystem. So we cover Scoop and Flume, we cover Hive, Pig, we cover Impala. We talk a little bit about HBase. We don't go into depth on HBase because HBase is an ecosystem project that some people need and some people don't. So we actually have a separate 4-day HBase training course, but the admin course does cover most of the key parts of the Hadoop ecosystem, yes.
Thank you, Ian. So the next question, is the administrator training appropriate for Windows mainframe administrators?
I'm assuming that's Windows or mainframe administrators. If you have no knowledge of Linux, then I would strongly recommend that before you come on the admin training course, you at least read a book or take an online tutorial that gives you the fundamentals of how to use Linux, because you know, as a Hadoop system administrator, that's what you're going to be using. You're going to be on the command line. You're going to be editing configuration files, that kind of thing. So if you have no knowledge of how to do that at all, I would strongly recommend that you at least take an online tutorial or sort of read a book on the subject before you sign up for the class.
Thank you, Ian. So next question coming in. So after taking the administrator training with us, Cloudera, will a student be therefore qualified to administrate any distribution, not only Cloudera's?
Yes, we are fairly distribution agnostic. Obviously, we use CDH. We believe it's by far the best distribution. However, other than a chapter where we talk about the features of Cloudera Manager, what we're doing, I mean, CDH is 100% open source. So CDH is Hadoop. So once you've finished the administrator course, if your organization happens to not be using CDH, then yes, you will still absolutely be well set up to go in and administer that cluster.
Thank you. So the next question is, someone is asking about the hands-on exercises within the course. Will they be sufficient enough for anybody who's lacking in real-world experience? I would assume they're asking if they'll feel confident enough to, you know, tackle an actual production cluster.
I think so, yes. We start with basically just bare Linux machines, and we install Hadoop from scratch on those machines. So by the time you've finished the hands-on exercises, you really genuinely have installed a Hadoop cluster. And if you've no experience of doing that before and you want to do that by hand, you can go back to your organization and essentially just follow the steps in our exercise manual to stand up your own real Hadoop cluster. So absolutely, taking the course, the hands-on exercises do give you completely real-world experience in building and configuring your cluster.
Thank you, Ian. So the next question here, how do we differentiate Cloudera Manager from Ambari, and which is best for administration?
That's a little bit of a loaded question, given that this is a Cloudera webinar. I would say Cloudera Manager is best. What Ambari is an interesting project. Ambari is, for those who aren't aware of it, is an open source project which looks to try and control management and installation of Hadoop. What Ambari does is essentially glues together a lot of other things. So Ambari has a lot of moving parts under the hood. It uses, I believe, Nagios and Ganglia and I think Puppet, and it kind of tries to put a unified front end on all of those things. Cloudera Manager is a single unified product. It is absolutely free. You can download Cloudera Manager without even giving us your name and address, certainly without paying for it. Cloudera Manager is a unified product that has had years and years of engineering work put into it, and it makes it almost trivial to install a cluster. You just put it at your bare machines and say, go install Hadoop on these machines, and it will go and do that, and it will then allow you to monitor and manage and configure your cluster. So if you haven't tried Cloudera Manager, I really, really recommend that you do. It's an incredibly powerful tool, and it's really solid, really robust. Ambari is a much younger project. It glues together a lot of things. It's a nice project, but it just doesn't have the road-tested, sort of production-tested features that Cloudera Manager does.
Thank you, Ian. Does this course talk in detail about Yarn?
We currently do not talk in detail about Yarn, and the reason for that is that we strongly recommend that right now people do not use Yarn on their production clusters. So Yarn stands for yet another resource negotiator. Yarn is another way of, to gloss over it, Yarn is basically a way of the next generation of MapReduce, if you like. And Yarn will also allow you to run other processing frameworks on the cluster. When Yarn becomes production ready, it's really interesting and really exciting. In the course at the moment, we talk about Yarn. We talk about the Yarn daemons, where they live on the cluster, and what functionality they provide. But we don't use Yarn when we're configuring our clusters because we don't recommend that people use Yarn in production yet. Yarn has just become beta. It's absolutely not yet production ready. It will be production ready at some stage. So if anyone is watching a recording of this, this is the end of August 2013 right now, and Yarn has just become beta. So when it becomes production ready, then absolutely we will talk more about it in the course. But right now, you shouldn't be using Yarn on your production clusters. So while we talk about it, we don't recommend it.
Good answer, Ian. So the next question here is, what does the administrator course cover in terms of performance optimization and reporting?
So performance optimization of a Hadoop cluster is a really difficult thing to do, and there are no silver bullets. Because what works really, really well on my cluster in terms of tuning the parameters may work really, really badly on yours because the kind of workloads that you're running are very different to the kind of workloads that I'm running. What we do on the course is we give you the knowledge and some suggested configuration parameters to tune your cluster's performance, but we give you the knowledge to understand what you're doing when you set those values, and we talk about how to monitor your cluster and then change those values based on your own particular cluster's workload. So it's not just a case of, here are 5 pages of values that you should plug into these parameters and everything will work perfectly. Instead, we explain what these parameters are doing, what effect turning a parameter up or down will have, so that by the time you go back to your work environment, you'll have not just some suggested starting values for getting the best out of your cluster, but also the real understanding of what those things are doing so that you can change them based on your own cluster's workload.
Thank you. So the next question would be, does the course cover how to take Hadoop beyond batch processing?
So taking Hadoop beyond batch processing is kind of a big deal right now. What the course talks about are other projects, things like Impala, which does give you essentially virtually real-time processing of your data. So we talk about how to install and configure Impala, and in fact you install Impala in a Handson exercise. So the course is about administering a Hadoop cluster, but as more ecosystem projects come along, we cover those ecosystem projects, and in particular we cover Impala, which does give you effectively real-time queries on your data.
Thank you, Ian, and with that I think we will mark this as the end of the webinar. Thank you again for joining us. Thank you, Ian, and enjoy the rest of your day.